So friends, in yesterday's lecture we discussed about distortion in power amplifier. We studied the details regarding the harmonic distortion, how it is going to present in the power amplifier. We also concluded that the distortion is less in the voltage amplifier, whereas it is present more in the power amplifier. Friends, today we are going to study FET as a common source amplifier. Student friends, we studied the FET, that is a field effect transistor, in BSc part first, where we have studied that FET means field effect transistor. It is a kind of a transistor in which output current is controlled by means of an input field. The output current is controlled by means of an input voltage. It is a kind of a voltage controlled device made up of the semiconducting material having four terminals, namely source, drain, gate and sink, in which current is conducted by only one type of charge carriers, that is only by means of a majority charge carriers. Minority charge carriers doesn't contribute in conduction of the current. Depending upon that, we studied that FET, junction FETs are classified into two types. One is N channel FET and second one is P channel FET. In N channel FET, electrons are the majority charge carriers. That means in N channel FET, channel is of N type and current is conducted only by means of an electrodes. In P channel FET, current is conducted only by means of an holes because the channel is of P type. We also studied that in FET, drain current is controlled by gate to source voltage. So that is the reason why FET is going to be utilized for the different applications, and hence it is a voltage controlled device or it is a field controlled device. We also studied in the last year, and that is MOSFET also. It is a metal oxide semiconductor field effect transistor. It is again of NMOS type, PMOS type, CMOS type, depletion MOSFET, enhancement MOSFET. So all those different aspects regarding the field effect transistors we studied in last year class, that is in the BSc 1. We are well aware that input impedance of FET is much higher than that of its output impedance, and that's fine. FET can be better used as a input device in many electronic instrumentation to reduce the noise and to pick up the signal as quickly as it is possible. Such a FET can be used as an amplifier, as like your bipolar junction transistor. FET can also be used in a different configuration. It can be used as a common source, it can be used as a common drain, it can be used as a common gate. Friends, here we are going to study how FET is going to be used as a common source amplifier. Dear students, please remember that we have studied up till now different types of the amplifier circuitries. We studied BZT as an amplifier in the different configurations. In common emitter configuration, common base configuration, common collector configuration. Each configuration has got their own specific properties. In accordance with that, FET has also some additional aspects when it is going to be used as an amplifier. Now we are going to study how FET is going to act as common source amplifier. Friends, common source means source is common for input as well as output. This means input signal to be amplified is applied between gate and source, whereas output is to be taken between drain and source. In this condition, we observe that source is common for input as well as output. Such a FET which is going to be used as common source for input and output to act as an amplifier, it is biased properly, especially either by using any of the suitable biasing method. Its operating point is going to be managed in a proper region so that it is going to act as an amplifier. Friends, such a FET as a common circuit amplifier circuitry is represented here. So this is the amplifier circuitry in which we are using FET as a common source. Students, this blue colored solid state device is FET. It is represented symbolically. We are well aware that the terminal on which the arrow is there, it is going to be treated as a gate, whereas this one is a source and this one is a drain. Sealed, it is not connected in most of the applications. It is obtained from the substrate. If you look to this particular amplifier diagram, source is common for input as well as output. If you look at input signal to be amplified is applied between gate and source, whereas output is taken between drain and that of source. Hence, here source is common for input as well as output. That's why it is called as common source amplifier. This FET to act as an amplifier, it is properly biased. If you look to this particular amplifier circuit diagram, it makes use of R1 and R2 as a voltage divider biasing network, which provides necessary amount of gate current, also to develop necessary amount of gate to source voltage, so that gate and source is going to be reverse biased and make it to conduct the current. We are well aware that gate and source of the FET should be always reverse biased, whereas drain and source should be forward biased. That biasing supply is provided in the form of power supply VDD along with the combination of R1 and R2 as connected in the circuit diagram forms the voltage divider arrangement. Its job is to adjust its operating point of FET exactly on the center of the load line so that FET is made to be operated as an faithful amplifier. Along with this, the source resistance Rs is connected that provides self-biasing to the FET. Capacitor Cs is going to act as a source bypass capacitor. It bypasses AC component to the ground. In addition to this, Rd is the resistance connected between supply and the drain. It is going to act as a drain resistance, or it is called as the load resistance through which the drain current Id flows. The input signal to be amplified is coupled by means of an capacitor C1 to the gate, whereas output signal to be measured at the output by any of the devices like CRO or any AC voltmeter, or maybe by using AC multimeter. It is connected between drain and that of source. Friends, this is what the construction of FET as a common source amplifier. Let us see its working. When small signal to be amplified is applied as a Vin or Vi, that produces a change in gate to source voltage. This produces change in drain current. Thus, change in gate to source voltage produces change in drain current. This produces voltage drop across Rd, that is a drain resistance, which changes the drain voltage. The input and output voltages are out of phase by 180 degree with each other. Means small change in input voltage produces large change in drain current, at the cost of which we can get output signal voltage to be amplified. After amplification, if you look to the waveforms of the input signal and output signal, it appears that output is 180 degree phase shift with that of the input. Look at here, if this is the signal, then output will be like this, which is totally reversed by 180 degree phase shift. Such a circuitry can be used as a FET as a common source amplifier. Friends, this amplifier is now to be analyzed so as to calculate its voltage gain, its current gain, power gain, input impedance and output impedance. Dear students, almost all we have analyzed BJT prior to this in the various configurations, and where we have calculated or we determined the voltage gain, power gain, current gain and also input and output impedance. Let us define today all these parameters and let us perform its analysis in the next period. Voltage gain here, it is a ratio of output voltage upon input voltage. In this case, V out is the output voltage, V in is the input voltage. Their ratio to be treated as the voltage gain. Similarly, current gain AI is defined as the ratio of output current to the input current. So that is ID upon IZ, or we can call it as IO upon II. Similarly, power gain, it is a product of voltage gain and that of the current gain. Input impedance is but natural. We can say that it is the ratio of input voltage V in upon input current I in, or V in upon IZ. output impedance, by rule we can define it as output voltage upon output current. By using these formulae and by making use of the small signal model of FET as an amplifier, we are going to perform the analysis of FET as a common source amplifier. Merely by replacing this particular FET by its small signal model, and then it is analyzed by reducing DC source to 0, by short circuiting the capacitors, and it is analyzed for AC analysis so as to calculate almost all the parameters of FET as a common source amplifier. Friends, that particular analysis we are going to perform in the next period. Today we will stop.